Okay, so when I graphed this, I ended up with an equation of my line of best fit being y equals 0.0899x minus 6 times 10 to the negative fifth. Okay, and so this is the standard way that we write equations here. So this is the y equals mx plus b. Now the plus b part, that's just where it crosses the intercept. We are not going to do anything with that, so we're not going to worry about that right now. But what we do need to look at is what is plotted on our y-axis and what is plotted on our x-axis. So in our graph, on our y-axis, you should have had force. And on your x-axis, this was 1 over r squared. Okay? And then our slope is m, of course. And our slope that we found by plotting everything is 0.899. So what does that mean to us? We've got force and we've got 1 over r squared. Well, let's think about the formula that we've been talking about this whole time, Coulomb's law. And it's force equals K Q1 Q2 over r squared. Now what I'm going to do is I'm going to just break this apart. I'm going to make this all just a multiplication rather than a division. And a way that you can do this is instead of saying divided by r squared, you could say multiplied by 1 over r squared. Okay? So that's what I'm doing there is I'm taking the r squared out and I'm just multiplying it. Okay, so now I've got F equals K times Q1 times Q2 times 1 over r squared. Look at this comparison here. Let it focus. Look at this here and compare it over here. I have my F, so that's like F equals, here's my F. I have my 1 over r squared. So what does that mean to us? It means that m is equal to K times Q1 times Q2. So that's what we just found. Our slope is equal to K times Q1 times Q2. And the whole purpose of this lab is to figure out what Coulomb's constant K is. That's what we're trying to figure out. So we calculated our slope with our graph, 0.0899 equals K times Q1. Now Q1 was 10 microcoulombs, which is equivalent to 1 times 10 to the negative fifth coulombs. So 1 times 10 to the negative fifth. And Q2 is equal to 1 microcoulomb, which is 1 times 10 to the negative 6 coulombs. Oops, 1 times 10 to the negative 6. So now what I can do is to find K, I can divide both sides by 1 times 10 to the negative fifth, 1 times 10 to the negative sixth. That cancels, and put it over here. So I'm going to put into my calculator 0.0899 divided by 1 times 10 to the negative fifth times 1 times 10 to the negative sixth. Okay? And what I'm going to have left over is my K. Where's my calculator? I don't know what I did with my calculator. Sorry about that. Okay, so I'm going to start with 0.0899. Hopefully this will focus so you can see what I'm doing here. Kind of. Let's autofocus. There we go. Divided by, and I'm going to put everything down here in parentheses. 1 times 10 to the negative fifth times 1 times 10 to the negative sixth, and close that whole parentheses, and I get K is equal to 899 and then 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7. So let's put this in scientific notation. How many do I have to go back to get to here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I end up with a K that's equal to, oops, hopefully this will focus, 8.99 times 10 to the 9th. And we always say K is equal to 9 times 10 to the 9th. Another thing is on your graph, notice that your r squared value equals 1. What this means to us is our data is very predictable. It's following a pattern to repeat the same thing every time. So an r squared value of 1 is telling us there's a constant. And so this right here, this K, that is our constant. That is the number that we are looking for every single time. So what Coulomb probably did is he probably took his information and he probably plotted force versus distance. He probably plotted force versus 1 over the distance. Maybe he did force versus distance squared. And then finally, force versus 1 over the distance squared. Now, it's probably more than just that. It's probably more than just a guess because this is the same ratio that happens when we're talking about optics. And we're going to get to that a little bit later. But you'll see this 1 over the distance squared again. So what we did in this whole entire lab is we were able to calculate out what that constant is. That's the whole purpose of this lab.